But the rating was so good.
Yep,
Yeah.
it's a good game. Good game. Tell me what your best time is on the first level. Try these for a couple of more minutes and then we'll do a tutorial. Or if you have questions now, we can do them right now. I think the hardest lesson we did recently was by parts. Were there questions you wanted me to do by parts? I can. Or do you want to try some of them now? It's not too bad.
The integration of simple rational functions.
Yeah.
I think you might.
Well, why don't you try a hard one to see if you can do it? Is there the last question? What is on the simple rational? Is that a constant over a quadratic?
Yeah.
Depressed quadratic or not depressed?
1 means 5 question.
Huh?
3.
There's 3. Yeah. If you can do that, then that's the hardest one on the page. I thought there might have been some weird by parts ones. Can I see? These are all. It's only these ones which are interesting. And I actually did this one. I actually did both of them in class, didn't I? Yes, I did. I did both in class.
Which one?
This one is only in. Well, this. You know what to do here?
Yeah, FF.
It's just sign it.
It's my turn.
Thanks.
That's actually an interesting one. I might want to do that one now. These ones.
Well, I'm the same like FG minus.
Yeah, it is. Yeah. But what will happen for these one is you'll need the rule twice.
Okay.
Here you'll need the rule infinite times. Here these are interesting. I think I'll ask people to do this one now to see if they can get it. All of these I think you just need the rule once. And these are the ones where you have to add in the number 1. Guys, can you have a look at page 28? And I want you to try 3A.
3A.
Yeah. Sorry, KJ, did I give you limits or not in 3A?
Yeah.
There's limits?
Yeah.
No.
Chrissy, do you mind putting the light on, please? It's getting a little bit dark. Thank you. Be good. Can you do that question, Jerry? Thank you.
What do you want?
Is that a question, Lee, or are you just talking to yourself?
No, I mean, what is the instruction?
What is the instruction? Calculate.
Thinking nowadays is very useful because nowadays cars
Yes, I know. I've seen a video of it being hacked. The wireless key. Yeah.
And if someone lose the key, and you can hack into the car and rebuild the key.
Yep. Yeah. No, I believe this.
It's a
Yeah.
good business.
Yeah.
Good business.
No, he's right. It is good business. It is good business. No, that's what I was saying to Jerry, that security will become more important in the future. Yeah, but I'm just saying, well, become more important. Is there a need for extra security in Malaysia? Because I've had a couple of Malaysian students want to study security, IT security. You don't know. It's not like a thing that's short on.
No. I had a friend that doing that business.
Security.
No, hack the car.
We see. Okay. So yeah, there is a need for more security in Malaysia. Then it seems to be a common problem.
Yeah, that's
And the funny thing is, it's the expensive cars that have this.
Modern cars.
Yeah, the expensive cars, not the old cars. The cars that people want to steal are the ones that have this problem. That's what I'm saying. It's a funny thing, you know.
Yeah,
it's like the BMW is the one that has this, or Mercedes or something.
Old car is better.
Yes.
Sometimes.
Or sometimes old phone.
Yeah. You know, because modern car.
Now the secrets are coming out.
Modern car is easy to break down, and old car is.
Yeah. I had trouble with, I have the hybrid car. Hybrid.
Yeah.
But it's actually 10 years old in June. And I'm noticing now the hybrid battery.
Yeah.
It's starting to lose its...
If you break down and you replace the hybrid battery, it's very expensive.
Oh, I know. It's like 3,000.
Yeah.
But I'm worried that the battery is about to break because it's losing its ability to charge. Like it charges very quickly and discharges very quickly. It's going like this. I would think maybe in about 3 to 6 months the battery might be dead. But I don't think I'll replace it because it's 3,000 euros. But I was told that even if the battery breaks, the car will still work. It just won't be hybrid anymore.
Sometimes old school is better.
Yeah, I think so.
I have a Toyota Corolla.
Yes.
The car. I can repair with a spanner and
Yes.
and
You don't need to connect it to a computer.
I don't need computer thing.
Yeah. No, I understand. Yeah. So this is how I feel about this. It's the same feeling.
Cannot break down.
Exactly. Reliable. Yeah. Okay, guys, how are we doing with this one now?
Interesting.
It's interesting. It's weird.
Yeah, it's really interesting.
Oh, I don't think.
zero.
Oh, I don't think you should get 0.
What's the derivative of that one?
What?
What's the derivative?
Who's the derivative? What's the derivative? What's the derivative of sine 2x? 2 cos 2x. Thank you.
Side track.
Derivative.
Oh, dude.
Derivative. Alright, can we do this one?
Yeah.
Yeah.
Monica, can you call out the question? What was it? Integrate.
Zero.
I'll put that in later.
Yeah.
dx. Okay. Can you look, guys?
Yeah.
This is integrate sine x. Sine x dx.
X.
Okay. F derivative.
Cosine.
G derivative.
Minus cosine.
So this now becomes
Minus sine.
F G minus F derivative G with another minus.
Yeah.
So this becomes
0.
minus sine x cos x plus integrate cos squared x dx. Now, how many people integrate again?
Me.
Yeah, and what happens?
I guess sine square
Yeah.
Yeah.
But watch this.
bring
One minus.
No. Yes.
1 minus sine square.
Good man.
what?
Watch this. You can change this. So I don't need to integrate again. I can change it into 1 minus sine squared, which becomes minus sine x cos x plus x minus integrate sine squared x, which I can take to the left and get 2 integrate sine squared x dx equals minus sine x cos x plus x. Divide by 2, and it's 0 to 2 pi. So 0 to 2 pi. If I put 2 pi in here, I'll get 0. So it's only going to be 2 pi over 2 minus, and if I put 0 in here, I'll get 0. So the answer is pi. And KJ is checking this on his calculator. If you integrate sine squared from 0 to 2 pi, do you get pi?
Teacher, why do I get different answer if I integrate?
Ah,
Yeah.
because you did it wrong.
Huh?
No.
No.
You shouldn't get a different answer. You should get exactly the same answer.
Minus sine s cos s
Plus.
plus sine s.
Yes, cancel.
It's cancel, yes sir.
0.
Yeah.
Do you not get pi?
No.
Are you sure?
Yes.
Cancel.
Cancel.
It cancel becomes
So what
zero.
Okay, hold on. I know it's look at me, Lee, Sean, look at me. I know it's impossible to get 0. Let me explain why. Because what does integration give you? Area. And what does the graph of sine look like? Sine is like this. But what about sine squared? Well, sine squared is always positive. So if I integrate, it doesn't matter where I'm integrating, I can only ever get positive answers. In fact, I can never get negative answers, nor can I get 0, because there's nothing underneath to cancel it. So I know 0 is impossible. I cannot integrate a sine squared and be left with 0. I can't, it's impossible.
Try to integrate again.
Oh, you
Like
just don't believe me.
Yes,
No,
because
I
three
know.
of us get the same answer.
Yeah.
No,
Alright. Alright,
fine.
fine. No. I have doubters. Okay. For you, I will do this.
Okay.
No, it's okay. Right, so I have integrate sine squared x dx equals minus sine x cos x plus integrate cos squared x.
Yes.
And you would like me to integrate cos squared.
Yeah.
And because I'm such a nice guy, I'll do this for you. So this equals minus sine x cos x plus brackets, and then I have this thing here, cos x minus sine x cos x sine x. So this is f g minus integrate f derivative, which is another minus
Yeah.
g.
Yeah.
Right? Now you're absolutely right, that cancels. So you end up with 0 equals 0.
Yeah.
Not, now note what you're saying, I'm not saying that the integration is 0. You've ended up with a result that says 0 equals 0. So you actually haven't found the thing I asked you to find.
Oh, that.
Oh.
0 equals 0.
Yeah? What do you want me to do? Scroll up. Now, let me just check the answer here. Integrate 0 to 2 pi. We need radian mode. How do I get radian mode in this thing? Shift mode, radian, and then, come on, sine x. It's calculating
Nice.
pi. I believe your calculator will give me the same answer. What? If this is about 0, what? Sine x plus x, yeah? Sine x plus x. What's sine x plus x? Plus x. When I put x is 2 pi, I'm only left with 2 pi. Because sine 2 pi is 0. No, just say, type it in. Don't believe me. Sine 2 pi is 0. Go on.
This one equals sine 0.
We all agree that my answer is right. That would be a good reason for it to be wrong. Happy? Yes. This one is a bit weird because integrating twice actually fails to give you the answer because the sine squares cancel. In fact, the only way to do this is with the trigonometry rule of sine squared equals 1 minus cos squared. It's the only way to solve this.
So
Yeah.
if we cannot find that with part of the rule, then can we use calculator to do that and then?
What? No. You can use the calculator to check your answer. Okay, continue.
Yeah.
I want to do something different and interesting with you. So I want to show you this kind of interesting problem, which relates back to, remember a couple of weeks ago we were talking about Fourier analysis, wave analysis. So have a look at this function. That's x, that's y, and the function goes like this.
Snake.
It's like a snake, yeah, like this game. And I'll also tell you that this point up here is 1, this point here is minus 1, and this point is 2 pi, and this point is 4 pi, and this is minus 2 pi, and this is minus 4 pi. So in other words, this square wave is repeating. So for example here, f of 0.5 would equal 1, because it would be like about here. F of 4 would equal minus 1, because it would be about here. You get the idea? Yeah. Now, what graph does this kind of look like? Yeah, well, it's not quite sine, but it kind of looks like sine, doesn't it? So what I'm going to suggest is that perhaps this is not quite sine, but maybe it's actually a bunch of sines added together. So like it could be something like, let me see, A1 sine x plus A2 sine 2x plus A3 sine 3x, etc. Like maybe it's a bunch of sines added together. Because it kind of looks like a sine, but we're not sure what. So maybe it's just some sines added together. We don't know how many sines, we don't know which sines, and we don't know how much of each sine. So it seems like there's a lot we don't know. We don't know these, and we don't know how far this goes on. So what the heck can I do? Let me multiply this side by sine nx. And I won't bother write out, but I will write a couple of them out. The first one would be A1 sine x sine nx plus A2 sine x sine 2x sine nx. Can you see what I've done? I've just multiplied everything by sine nx. So why bother doing that? Well, the next step is let me integrate. So I'll integrate everything. And I'll also integrate from 0 to 2 pi, 0 to 2 pi, 0 to 2 pi. Okay, so let's see what we get here. So, let me see. This is a odd function. This is a... Oh, I'm sorry, I didn't mean 0 to 2 pi. I meant minus pi to pi, minus pi to pi, minus pi to pi. Okay, so now I want to integrate this. So I'll need to do this on the side. Now, when you look at this, you realize these are all the same type of problem. They're all like this. Some number, integrate sine, some number, multiply sine, another number, dx. Can you see that? So rather than doing it for each and every one, I'll just do it for this one and see what result I get. And then I just change the m. So for this formula, I should use m as 1. For this one, I should use m as 2. So, what rule do I need to integrate that? Well, that's a by parts, isn't it? A bit like the example I just did a moment ago. So let's see what we get when we integrate this. Okay. So, let's draw our thingy here. Sine mx. And this one here will be m cos mx. And here this is sine nx. And who can tell me what this one would be?
Minus.
Yeah, minus cos nx. And where do I put the n?
In front.
No, over actually. Because it's integrating. It's actually a substitution. You could make u equal to this to integrate. Okay, so let's see what this integration, I'll just call this integration I. So I m equals f g minus f derivative g. Is that right? No, sorry. Minus f derivative and another minus cos nx. Yeah, okay. All over m. So now I get im equals minus 1 over n sine mx cos nx plus m over n integrate cos mx cos nx dx. Okay, now we have to integrate this, which will be a little bit hard to do, right? But actually we can't continue with this because we haven't done this lesson yet. This doesn't come up for another 10 pages. We'll have to stop here. I know. Now you're not going to know how it ends up. You know what I'll do? I'll actually use the program. So I'll give you the answer, but I won't show you how to get the answer just yet. Okay, so let's see. No, I won't. I won't even do that.
What?
I'm going to leave you hanging. I have to. This is going to be to be continued. Yes, season 2. Yes, this is the end of season 1 cliffhanger.
Nice.
Yeah. The long and the short of the story is this. What's going to happen is you'll find out that, and I think I made a mistake here. You'll find out a lot of these you can simplify, and you'll be left with just you know what, I'll give you an easier version just to give you a flavour of what's happening here. Sin x. You could say that sin x is equal to a0 plus a1 plus a1x plus a2x squared plus a3x cubed and so on. In other words, you could try to find a formula for sine. Now the problem here is, what the heck are the a's? But there's a kind of a little trick here. If I put x as 0, what will this be? What's sine 0? This will be 0. If I put 0 here, what do I get? 0, 0, 0. They're all zeros except for the first one. So I have my first one already. Great. Only a few more to go. Infinite number to go. Well, how can I find A1? Well, you could do this. You could differentiate. So you could get cos x. What's the derivative of A0? 0. The derivative, it's a constant. What's the derivative here? A1x. And the next one? Oh, sorry, just A1. And the next one? 2A2x. And the next one? 3A3. Alright. Now, if I put x as 0, what do I get now? That's a 1. That's an A1. And what's all this?
0.
So now I know A1. Okay, let's do one more. How could I get A3? Well, I could differentiate again. What's the derivative of cos? Minus sin x. A1 becomes 0. What becomes here? 2A2. And the next one is 3 times 2 A3x. And so on. What do I do now to get the A2?
0.
I make x 0. So what will this be? 0. And this will be A2 and plus 0. So you get A2 is 0. So what's happening with the A is
0,
they're switching between 0 and 1. Although the next one actually isn't 1, because the next one, if you look, it will be this. What's the derivative here? 3 times 2. Yeah, it's going to be 6 A3x. And when you differentiate that, you get 6A3, which will be, so you get A3 then will be 1 over 6 when you bring it across. So what's happening is this. A0 is 0. A1 is 1. A2, 0. A3, 1 over 6. A4, 0. A5, 1 over 24. Because these are going to be, every time you bring the power down, it's going to be a 4 comes down, and then a 5 comes down. Yeah, so it's going to be an equals 1 over n factorial if n is odd. If n is even, it's 0. So I get this formula. Sin x equals x, x plus, what do we say the next one was? 1 over 6 x cubed. The next one was 1 over 24 x 5, and so on. Now, if you think about it, this makes sense. This function here, sine, is odd. This one, odd. This one, odd. This one here, odd. This is kind of the idea I want to give to you. Because this is a wave function, then we can write it as a sum of wave functions. So I could write it as a bunch of sines added together. Because this is an odd function, I can write it as many odd functions added together. Let's test this out. Sine of 1 is 0.84. Okay, so let's see if I put 1 into this, what I get. 1 plus 1 over 6 plus 1 over 24 plus 1 over, what would be the next one?
3, 5.
We'll just do 3 of them.
7.
Whoops, that's not right.
5 over all. Okay.
Yeah?
1 to all. It's not 24.
Oh, it's not?
It is 5.
Oh, sorry, thank you.
Yeah.
Yeah, 1, 2, 0. Oh, I skipped. It's not 4, it's 5 then. Yeah, okay.
And then 5 over all.
Oh, no, I made a sign mistake. I forgot there's
To be continued.
Please. I can do this here. Yeah, there's a minus on this one, sorry. That's the formula I should have gotten. Okay, sub x1 simplify, approximate, yeah, and then on the calculator, sine 1.
Oh yeah.
Anyways, this is actually what your calculator is doing when it calculates the sine. So your calculator is actually doing this. Probably something like maybe 100 terms. Oh, okay. 20. Oh, variable field. 1 second. I want to get my Taylor series.
100.
There we go. So when your calculator calculates sine, it's actually putting it into a formula like this to get it. Because think about it, how does your calculator know what the sine of something is? Like, does it draw a triangle?
I studied maths before.
Yeah, it didn't. It's just using a formula like this to calculate the value of sine. That's all that's happening. Yeah. Like, if I put 1 into this, it should be pretty accurate. There you go. Same. Yes.
I have a question.
Which one?
By substitution.
Yes. Read it out to me.
Wait, no. Ln 2
Yeah.
and integrate sine.
Oh, this one.
And
Yeah, log 2. No, log 2. Integrate, yeah.
and
2
to the power of sine x.
sine x.
And then
Oh, I
cos
like this
x. And dx.
Good and juicy. Right, did anyone try this one?
Yeah.
And did you get it?
So,
Fail. Fail. Succeed. Right, so what do you make u equal to?
sine x.
And what does du dx equal?
Cos x.
So what does dx equal?
Du over cos x. Minus.
No, that's right. So this is equal to log 2 integrate 2 power u cos x du over cos x. Nice. So this is equal to log 2 integrate 2u du. Okay. Yeah? Are you making fun of me? Log 2 integrate
E log 2u.
e log 2u, because all of this makes just 2. So that is integrate log 2
Oh.
e log 2 u du. And that's actually just integrating e kx. It's in the formula book. It's just going to be log 2 e kx, in this case log 2u, over k, in this case log 2. They cancel, and you're left with e log 2 with the u. But you know, you can bring the u back up, so it'll be e log 2u. Oh, what's e log 2? True. And what's u?
Sine x.
Yeah, you want to write that down, huh? Wasn't that juicy? You don't like it, Sean? Don't like it. Give me a juicy one. Oh, juicy one. The sine squared was juicy. That was a juicy one.
I have a question.
Yeah.
It's about the integral.
Is it good?
I just wonder, like, if we have like sine square like that, if we integrate this, like that.
Are we talking about rotating or area?
Area.
Yeah.
And this variable.
Yeah, so it's like 2 eggs.
But my question was like when you do like this graph and want to do this before,
Yeah.
if you integrate this goes too, like that.
Yeah.
So it's going to be just this. It's 1 over n. Isn't it n?
Huh?
I mean about the area.
The area or the volume?
Area.
The area of that, both those graphs will be 0. Well, I mean, okay, the area is not zero, but if you integrate, you get zero, because the positive and the negative cancel.
Yeah, that's what I wonder about what you did before about that, something like this. Yeah.
I don't forget about that. Sorry,
I
that's,
mean, it's going to be, if you integrate that, it's going to be like all positive, the negative will go up. So it's just,
the negative only goes up if you square it, if you're getting the volume.
oh, so it's not infinite.
It's not because it's an integral, it's because it's a square in the formula. You know, so that's why I said it's impossible to get a negative for the area, for the volume, because the square in the formula guarantees everything has to stay positive. Like fx is positive or negative, but fx squared is always a positive function. So integrating something that's always positive can only be positive. It's impossible to make it negative. Huh? Who's calling me? People keep calling me. Oh, help me hack into the government. I can't, I'm busy. Oh, you didn't hear that, sorry.
It's only 2,000. You should ask for more. I mean, you can fund around the stuff.
Well, I can't ask for more because I can't do it.
You can ask for more and then you don't do it.
You got a juicy one for me?
Yeah,
This isn't juicy.
no?
No. This is as juicy as it gets today. Maybe next week will be juicier for the tutorial. Oh, I'm actually. Let's see what's coming up in the next few lessons.
Yeah, 5 million.
Oh, yeah. Juicy. What are the answers?
Oh my God. Is it all mixed together? Which page, Andrew?
Everything comes together in this. It's like Lord of the Rings of integration.
Which one?
This one.
Which one?
Page 38.
38.
What?
Sometimes it takes 2 hours to do that lesson, page 38.
Teacher, what career do this? I mean, is there
Wow.
any career to solve this every day?
Engineering.
Seriously?
Advanced engineering.